In this video, I will discuss about the question 8 in the homework 7. Let's see the description of the problem. We are given the definition of Poisson process and it has several properties. The first property is the number n t1, t2 of the point ti in the interval t1, t2 of length t equals t2 minus t1 is a Poisson random variable with parameter lambda t, and the probability of n t1 t2 equals k equals e to the power of negative lambda t times lambda t to the power of k over the factorial of k. The second property is if the intervals t1 and t2 and t3, t4 are non-overlapping, then the random variables nt1, t2, and nt3, t4 are independent. And the third property is at a time moment t, there is no more one Poisson point. Using the points ti, we form this process xt equals n0t. The first problem is to find the expectation of xt. We know the ext equals en0t, and it's easy to get the answer. It is lambda t. The second problem is to find the rt1, t2. First, let's assume that t2 is larger than t1. Then n0 t1 and nt1 t2 are non-overlapping. Since t1 is less than t2 and they are independent Poisson random variables. So the expectation of n0t1 times nt1 t2 equals the expectation of xt1 and times xt2 minus xt1. Because they are independent, it can be wrote as the expectation of xt1 times xt2 minus expectation of xt1 times xt1, and it equals rt1 t2 minus expectation of xt1 squared. We know that the expectation of xt1 squared is lambda t1 plus lambda squared times t1 squared. So the rt1 t2 equals lambda squared times t1 times t2 minus t1 plus lambda t1 plus lambda squared times t1 squared, which equals lambda t1 times 1 plus lambda t2. And if t2 is less than t1, it's easy to get the rt1 t2 equals lambda t2 times 1 plus lambda t1 because there's symmetry. And to summarize both cases, we know that the rt1 t2 equals lambda squared t1 t2 plus lambda times mean t1 and t2.